All right, so again, we find ourselves in a situation where, despite being a calculator section, a calculator is not useful. So we're told that f is a function that is twice differentiable from -2 to 2 on that open interval. It satisfies the conditions in the table, and we know that f of x equals f of -x, right? So what's that? What that's saying is that f is an even function, right? This is the definition of f of x is an even function, meaning it's symmetric about the y-axis. So this is symmetric about the y-axis, all right? So what are the x-coordinates of the points of inflection? Okay, so here's the deal. We see that f double prime is negative on this window and positive after, so there's definitely a point of inflection when x equals 1. But because this graph is symmetric, so if we were just to try and draw this, right, here's the idea. So here's 1 to 2, right, and here's -1 to -2. And it is helpful, I guess, to draw it. It's up to you, right? So we know that on the window from 0 to 1, right, so from 0 to 1, f is positive, f prime is negative, so it's going downhill, and f double prime is negative, so it's cupping down. We know that on the window from 1 to 2, f is negative, right? F is still going downhill, but now it's cupping up. So basically what's happening is we have a graph that is cupping down and going downhill, but above the axis, and then still going downhill, but now cupping up and also below the axis. The graph kind of looks like this. Since it's symmetric about the y-axis, it's going to look like this. So if this is a point of inflection, this is also a point of inflection. So our answer is going to end up being D. You don't have to draw it. That's kind of the idea, though. If that helps you, it's a little bit easier to see it visually.